So welcome back to our CodeWars series dedicated to solving CodeWars kata. And in this video, we'll be solving one level 6 kata called difference of 2. And we'll not only be solving it, but we'll also be solving it a few different ways to show how you can reduce the runtime and make the code more efficient. And at the end of the day, that's what we're all after, is a more efficient, better code. So in this kata, the objective is to return all pairs of integers from a given array of integers that have a difference of 2. The resulting array should be assorted in ascending order values, and we're to assume that there are no duplicate integers in the array, and that the order of the integers in the input should not matter. So here we're defining our two differences, and we're inputting a list. And so first, since we want an answer in a list of pairs, we're going to want to define an empty list called answer. And then also before moving on, we're going to want to sort our list. And what this will basically do is make sure that when we loop through our list and determine our pairs, we'll be getting the smallest integer first, because this is the way the question is phrased, wants the output in ascending order. So what will happen here in this test case, you'll see we have 6, 3, 4, 1, 5. This will sort it so that it goes 1, 3, 4, 5, 6. And so we're going to be looping through our list one element at a time. So for lm1 in LST, and we're going to loop through that list again. This time we're going to call it lm2 in LST. And basically what we're doing here is we're looping through twice so that we can compare the two numbers to each other. And so, if lm1 and lm2, if the difference between those two is 2, then that's part of our solution here. So we're going to want to use an if statement to determine that. So if lm1 minus lm2 equals 2, and we want lm1 here, then we want to be appending those to our answer list. But depending on how we append it, we want the lower of the lm1 lm2 combination to appear first. So I use another lm statement or if statement. If lm1 is greater than lm2, then we want to append to our answer. We want to, since lm2 is smaller, we want to append that first. So lm2 comma lm1. And it's actually important here that we wrap this append in double parentheses, because we know we can only append a single parameter to answer. And so if we did it with just this single set of parentheses, it would think we're passing two parameters, the first one being lm2 and the second one being lm1. And so we're going to do this again for the opposite when lm2 is greater than, we don't want that, we want backspace, and then there. So we're just going to go ahead and reverse this as well. We could have also done just a plain else statement here. This would have worked fine too. But just to show our thought process and what we're doing, we're just going to use that. And so at the end of the day, we're just going to want to return our answer list. We're going to go and test it. And as we're testing, we see here that we're using a nested for loop, which isn't the most efficient way to solve the problem. If the list had 100 elements in it, then we would be parsing through it 100 times. And then inside of that, we're parsing through it 100. So we would be parsing through it 100 times 100 times, which is 10,000, which is a pretty large amount of time. And obviously we want to reduce that. So if we could somehow not nest our two for loops inside of each other, then that would definitely reduce our runtime a bit. So that's exactly what we're going to do. So for this solution, for our second solution here, we're going to be using a second list. Let's call it list 2. And we're also going to be defining it as an empty list at first. And we're using this because as we parse through our list once, we're going to be appending to this list 2 the answers that we hope to find in the list. So that means that when we're going to be parsing through, let's take this example list here. We're going to be parsing through 1, 3, 4, 6. And so for the first element, which is 1, we're going to be appending into list 2, 1 minus 2, which is -1, which is the pair that we need to append to our answer list before we return our answer. And so that's a little bit hard to visualize. So let me just go ahead and run through this here. So for I in LST, so again, we're looping through our list here. we want to append to list 2 I minus 2. Oh, we don't want colons there. And now, since our list 2 is sort of our solution set to our original list, we're going to want to loop through that list and determine if, so if J, let's use J in list 2. So once we loop through this, we want to see if the solutions, which is list 2, lie in the original list. And if they do, then we want to obviously append those to answer. So if J in LST, we do want a colon there, then we want to append to answer our J and then J plus 2. And again, we need double parentheses here. And yeah, that should do it. So we're going to go ahead and test that here. Looks like J is not defined. We want this for J in list 2. Okay, so we're going to go ahead and attempt that. And so here you can see that we got the, we passed the test again, so we got the solution correct. But here you can see that we're using 2 for loops, but they're not nested. So this time, if list is has 100 integers in it, then we would be parsing through it 100 times. And then, list underscore 2 would also have 100 in it, so it'd be 100 again. So we'd be passing through 200 times, which is definitely a lot less than 10,000. But there's still an even faster way to do that. So once again, we're going to delete some of this. We're going to keep our answer list being declared as an empty list, and then our sortation of our LST list. And so for this time, we're just going to be using one for loop. So for num in LST, if num plus 2 in LST, then we want to append to answer num and LST, or num and num plus 2. And again, we're using double parentheses here. And you can see here, so for every number in list, we're checking if that number plus 2 is actually in list already. So we don't have to use 2 for loops, we just have to use 1 for loop. And then if so, we will be appending those 2 numbers to answer. And we get to solve this with just 7 lines of code here. And you can see here, as we run through our tests, we actually only use 1 for loop. So again, if list had 100 elements in it, we would be only parsing through that list once. So we'd be parsing through 100 times, which is a lot less than 10,000 and still less than 200. So thank you for watching this video. If you have any suggestions on how to speed up this process even more, or you want to comment on any different solutions, we would definitely appreciate that. Thanks. Bye-bye.